Going live now. Yeah. I'm turning mute and going away from Zoom.
Okay. Hmm. All right. So, hi everyone. This is Sandeep Giri. I hope you are able to hear me and see my screen clearly. So wonderful to see all of you from different backgrounds and from different countries. And I'm I'm hoping that I'll be able to match up with your expectations. So these Wednesday project talks are designed to make you hands-on, specifically in the AI and engineering and software domain. All right. So this is kind of experiential learning whereby you have an end objective in mind, and then we walk to that end objective. So this is, I think, fifth session in the same sequence, and I'm really happy to see so wonderful people joining this webinar, and from different countries. And I'm happy to see Peter. Hi, Peter. Great to see you here. And we had a great time in South Africa. And we have Sherry. Sherry is somebody who joined me in last couple of sessions as well. Wonderful, wonderful to have you in this. And I would love to answer your question before moving forward. Okay, so about myself, I am Sandeep Giri, and I have very decent experience with respect to building and deploying large scale systems. I worked with Amazon detail page, the one that you see on Amazon.com from mobile. When you click buy now, that page is something that I built. If it vibrates a little bit when you click on buy now, that means you'll be using the app that I built when I was working with Amazon. And I have been building things at CloudxLab. This is my own startup, and whereby I have, along with my team, my co-founder Abhinav, we basically have built the entire lab on the cloud, which has changed people's life and which has made people really experiential learners. We have seen in past that most of our learners have become very problem solvers, and that is something that I enjoy as part of my work. That most of the learners who have come to CloudxLab, who have learned at CloudxLab, they are successful in their respective domains, because our hypothesis is that if you become hands-on, or and you become a problem solver, you will be able to solve industry problems, as well as you'll be able to land up a job, because in the job people are asking for the hands-on, and thereby this is a way to success. And wonderful to have all of you. So basically, about myself, I am Sandeep Giri again. And coming back to one question, very interesting question that Sherry has mentioned. Not question really, it's just a discussion. It's about how do you start with teaching programming to kids. Okay, and that's a subject that I'm really obsessed with. I have a 9-year-old, and I'm trying to teach him coding, not by force, but by making him play with it. So sorry for the digression, but I would love to explain to everybody who had joined this meeting today. So what happened was, right, my kid was playing this game called Roblox Jailbreak, and I felt bad that he's all the time on the computer, on the screen, and I mean, is it useful for him or not? So what I did was I started playing the game with him. Instead of asking him to stop, I started playing the game with him. That way I connected better, And luckily, when I was playing Roblox Jailbreak, these guys, the kids, actually were very nice, and they were able to connect them with me better. And and of course, I have forced him earlier to play with my electronics and play with other things, but I realized that I was connecting better when I was playing game with him. I was seeing that he's actually very considerate. He was helping me with the points. Then one interesting thing happened, that I bumped into this Roblox studio. Okay, now, in Roblox Studio, I mean, that's again somewhere my kid only told me that using Roblox Studio, you can design Roblox games. So I started fiddling around with it, and then I realized that it's actually very simple to design such complex games. And me and my kid both together started watching videos on how to make this, how to do this, how to do that in that game. And this way, we started watching those videos together, and then he started learning the coding from there. And yes, so essentially, right now he is himself very inclined, and even in my absence, he's trying to figure out how to build something, how to write a if else condition, how to write a loop. He's figured it out by watching videos. So so I did not teach him at all. Instead, I made him I gave him the environment, right? So that's something, a subject very close to my heart, that how do you teach? In my role, I teach three people. Okay. Now, I mean, again, pardon me for digressing, but this is extremely important. In my role, I teach, number one, I teach my 9-year-old. That's the first thing. Second, I teach people, like people who come to my classes. I teach them machine learning, and machine learning, big data, DevOps, full stack engineering, data structures, all those things I teach. And third thing I teach is to machines. Okay, I teach machines like how to write, like lots of systems that we have built recently using machine learning. So and so I teach these very three different entities, and my common learning is okay, let me quote it, you can quote me on this, that everyone learns by examples. Everyone learns by examples, whether it's machines, adults, or kids. Nobody learns by theory. Nobody learns by theory. Okay, so I mean, we could I have tried multiple times teaching people what I have in mind. I end up and try to put on theory over and over again. I found that people either misinterpret the theory. Second, people forget the theory. And when we are teaching somebody theory, other persons are basically memorizing that theory. They are not really learning. Real learning is by examples. You see one example, you see another example, you see third example, and you basically form a correlation between input output. And when we say we are playing tennis, so where are the examples in playing tennis? Look at it closely, right? When the ball is coming, right, and you are swinging your racket. So it's an example space for your mind, right? Example space in the sense that when the ball is coming at this angle, I have to swing at this one. And was it successful or not? You know this. So this playground is generating examples for you. All right. So this is a important part about it. And the second learning I have is that overfitting, underfitting that I have taught in the classes, that applies to everybody, right? Overfitting, underfitting, regularization. It applies to humans. It applies to machines. Okay. So that, let's start with the agenda that we planned today. So wonderful, wonderful. There was one more question that I want to take right now. The question is, which language I used at Amazon, and how good you are at that language. Okay. Okay. This is an interesting question. Okay. So let me time myself on it. I will take 2 minutes to answer this question, not two, maybe more. Okay. Let me see. All right. So this is a very interesting question, and I get asked this question very often. So question is, what language is good, and how good I have to be in this language in order to succeed? Okay. Now this is the important part about it. Okay. So number one, at Amazon, we used very different kind of languages, and in every job I have gone to so far with D, Shaw, InMobi, Amazon, and in my own startup, I ended up working with a new language every year or every 2 years. And that being said, I went through close to 14 languages in my career, in my 20 years of career. And my learning is that learning language doesn't teach you physics or science. Learning language only, I mean, I'm just taking an example of natural language, like, so the science is same in all the languages, right? Therefore, if you understand science in one language, you will be able to do science in another as well once you learn the syntax of it, right? The beauty about programming language is that no matter which language you learn, right, no matter which language you learn, you will be able to accomplish the task in that language, right? Except for few languages, like say, for example, SQL, those are not really Turing complete. So it becomes really difficult to have the for loop and so on, right? But languages like Python, Java, Scala, Go, and every other language, they are equally capable, and you can achieve in all of that, right? So my suggestion is, pick any language. Trust me, you become good at constructing your thoughts into code, converting the thoughts into code, and you will become good at every language. It took me a long time in my beginning of career to learn C, but later on, I was able to move to any other language very fast, very quickly. It did not, I was like, for example, when I never worked in Python. The moment I joined InMobi, I started working with Python and was able to get the whole system up and running in, say, 15 days of time. So the important part is, the first language takes time, but remaining languages are analogous to the first language. Therefore, the languages do not take time. However, what takes time, when we say I'm good at language, you are not good at language, and nobody should be proud of being good at language, right? You should be proud of constructing, creating code, to solve a problem. Like, for example, do you understand recursion? Do you understand backtracking? Do you understand how to do dynamic programming? How do you do the graph processing? How do you build a web app? Do you have an understanding of web app? So those things change you, and they remain same in all languages, right? So, like, coming back to the question, at Amazon, we had some part of the application in Perl, some part was in Java, some part was in Python, and they were individual services. That's another topic for today. I'll talk about that part, and I'll show you that how different systems running in different languages would work together happily. Okay, so coming back to it, I hope I was able to answer your question. The answer is multifold. Number one, which programming language you use does not matter. You start with one, you will move to another, right? Now, second is, any system. Every time you use a system, it might use multiple languages and so on. Okay, and and so on. So the great part about programming languages is that if you learn one language, it'll be easy to pick up any other language, programming language. The natural languages are hard. They take probably 1 year or 2 years, or maybe say 5 years of time to become fluent for different people. But programming language, you can switch the context very quickly. Okay. And yeah, the most important part is to structure the logic. Let's say I ask you, given the list of numbers, find me a number. Okay. And in how many ways can you do it? Or give me intersection of these two lists. Like if you have one list and another, find the common between them or find the union, and so on and so forth. So once you know one programming language, you will be able to do it in other programming language. Similarly, all the data structures, algorithms are same in all programming languages, be it hash map, be it a set, be it array list, be it a list, be it a map, be it a graph, be it a directed acyclic graph. Everything, all the algorithm data structures are similar or same in all the languages. The concepts are same. Okay, wonderful. With that, this was wonderful set of questions, and I think this was useful for all. Feel free to let me know in the comments if what I said was sounding too much uh, abstract. Okay, all right. Wonderful, wonderful. So learning natural languages, human languages are very hard. It took me a long time to learn English, for example, but learning programming language was way more easier. First language is hard, wrap around your head to variables, to expressions, to if else conditions, to for loops or infinite loops, or to objects, to and so on. All right, wonderful, wonderful set of questions. So let's move ahead. So today the agenda is, what we're going to do is we are going to build a we are going to build a deep learning model which will recognize objects, which will recognize object. Okay, so there's a question from Aditya that can you please summarize? Okay, so I think you can watch the video. It was out of context, so nothing to worry about it. Okay, so I talked about a couple of things. I talked about what it means by learning, uh, and what it means by teaching, and I talked about the programming languages. So this video will be available to all of you. Do watch it. Okay, so that was out of context. Nothing to worry, Aditya. So I'm going to start today. I'm going to start today the how do you build a highly efficient system. Okay, so problem statement is this: we will build a website, we will build a website we'll build a website, and this website will be streaming, will be recognizing objects. And the last one that we built here in the last weekend, that one was slow. You must have noted that that one was slow, correct? And that thing is not practical, okay, because it was slow. Therefore, today what we're going to do is we're going to take this web application and break it into parts and make it like two different services and make it really, really good. Okay, so that's going to be the agenda. Okay, so let me also open an empty tab. Let me describe what we are going to do today. All right. So imagine we have a web application, right? This is our web app. Okay. So this is our web app, and users are giving an image. Users are giving an image, and we are telling what exactly is this, right? So this is a classification system, and this web app, what it does is it handles the request and extracts the image from it. Okay, this is the image that is coming from the user, and this is like what class is it. Okay, and we used a pre-trained model. So this web app, what it was doing is when this request comes, it it basically does these following things. Okay, uh, it first loads a neural network model, right? And then ask neural network model to do the prediction. Okay, and then it returns. Okay, so as if the as user is uploading image, okay, the the as user is uploading image, the web application The web application is inferring that image and giving the classes of it. Okay. And this web app internally is taking this step. First, it loads the neural network from the disk. Then it does the prediction and it returns the classes, right? So this is like we are using a pre-trained model. This is a pre-trained model. And from that we were doing it. So this part was taking close to say close to 9 seconds, I think. Okay. And this one is taking close to like a couple of seconds, and then it doesn't take any time. So effectively this process was taking close to 10 seconds, or I mean 5 to 10 seconds, right? This is not practical, right? Because you cannot make your users wait for that much time. Similarly, if like every user is asking for this over and over, what will happen is, so those many processes will do the same thing, right? So what can we take out? What can we make common? Loading the neural network, we can make it common. This part, we can take it out and keep it ready in the memory. So usually what people do is we create something called caching services, or keep it in the memory, right? So the difference between keeping in the memory and right. So again, let me try explaining again. So loading neural network has two parts to it. Number one, it loads that data, loads that model, the brain of it from the disk, right? From the disk. That takes time. Second, constructing the neural network takes another time, right? Therefore, even if we keep these data loaded in the memory and then construct the neural network every time, it's still going to be taking time. So usually what software engineers do is they put the caching layer so that you don't have to read from the disk. Okay, those who are new to all of this, let me explain something quickly. So when you are reading a file or reading some data from the file, that takes way more time than the memory. Okay, so there is something called RAM, random access memory. In the random access memory, you can address, you can quickly jump to any address, right? In case of the disk, or in case of the hard disk, you have to go sequentially, you have to rotate it and then start reading the bytes from the data, from the system. So coming back to it, so essentially there are two different psyches that work when we are reading the data. File or disk means sequence of bytes. The in-memory means addresses and jumping to that addresses, right? And therefore it takes time to read from the disk because it's slower. Physically it is slower, right? Therefore, what people do is they keep everything in the memory, which is as required. Correct. So I hope this was clear. And all right, let's move ahead. Perfect. So you can right, this one we have done earlier. Now we are going ahead with this one. Okay, so you can go to explore courses. Okay, when you click on explore courses, you will find something called this one. Okay, these are free projects. Anybody can pick them and start using them. Okay, this is open for all. And the only right, so these things are pre-installed in our lab. If you do not want to use lab, you can install in a local system, but it'll be great if you guys take up the subscription, because that's our way of sustaining the business. All right, so this is in continuation with the previous project, this one. If you observe, the amount taken earlier was close to 10 seconds. Okay, and right, so what we will do is we'll bring down 10 seconds to zero point 0.2 seconds. Sounds crazy, right? It's like 50 times. No, it's like yeah, 20 time 20 times, right? From 10 seconds to this, right? No, 50 times. Okay. So so we are going to improve the performance of the app that we built earlier to 50 times. Okay. So in the last discussion, what we learned was something important. Okay. Let me open it in a new window. Okay. Okay. So there is a question. Question from Sumit is, what was my IIT main rank? Okay, so I got a not very good rank in IIT main rank. I was getting IIT Delhi, some like really you know bad branch. So I took University of Roorkee that point of time, but then University of Roorkee became IIT. All right. So I hope that answers your question. And it doesn't matter in a long run. Honestly speaking, those who are from India, those who are listening to this, my suggestion is that even if you go to IIT, you will again have to give the interviews where the Google takes from every college, Amazon takes from every college, we hire from every college. It doesn't matter. What matters is your understanding of things and your understanding of technology. All right. So don't worry about it. Don't worry about it. If you do not get IIT JEE good rank, it doesn't matter. All right. So it doesn't matter in the sense that at the end of day, it's your hard work. At the end of day, it's your interest in the subject, and and the discipline that you bring in. So uh, I mean, that's what I actually am able to see in my career. I've been like 20 years into the industry, not 20 years, no, 19 years. Yeah, next month I'll complete 19 years. And but I have been coding since my first year. I created company when I was in college itself. So so this is like my passion. I enjoy teaching people, I enjoy guiding people, and that's what I did at my I mean, I helped lots of engineer at my first job into becoming a good engineers in the sense of security, in the sense of secure coding and so on. And in the same line, I'm doing it right now. So we are helping people learn technology. Okay, so it doesn't matter your JE rank and your school grades. All of that doesn't matter after a point of time. If you follow your passion, things will work out. Okay. All right. So I once started a restaurant in my career, and it was a pathetic failure because I didn't like it. I was never a foodie, neither I was a good chef. So it did not work. I did not enjoy the journey, but it was a good lesson to learn. So do the things that you enjoy more. Okay. So yes, okay, very good question. One question that is there, that how can I check the time? So one simple thing is you can just print the time in stamp on before and after, right? You remember that if you okay, so this was the web app that we created last time. Okay, this was the web app that we created last time, and it worked pretty well. It worked pretty well, and those who are not aware of, we basically created a full-fledged web app. Okay, So we created this folder structure. This was the folder. This was the Python program, which was basically the entry point. This was the entry point. This was the one which was calling the model. And these were the HTMLs and other things that we were serving. This one here, layout and upload, these were the templates that we were using. Index was the one where people are coming, like we are showing this index.html when people are coming to our website. And then upload was the place where people are able to upload the image. Okay, so let me just show you quickly what we built last time. Okay, so let me go to image classification. This was the folder, right? So this was a folder. And in that, you can see that we created this. Okay, those who are new to this, those who are new, who did not come previously in this session, I'm just giving you an overview that we built this structure. This is our web app, and it works pretty well. Let me go to the last page and show you what does this web app do. So this is essentially, let me activate the environment. The way you activate, what is an environment? Environment is a place where you can install other things and do not have to worry about any dependency clashes. Okay, so that's the beauty about the new genre of things, that you can actually create your own environment even at CloudxLab, where you can install whatever you like and you can destroy it once you are done. Okay, and this, what we are learning today, overlaps with DevOps, overlaps with full stack engineering, and it overlaps with machine learning and AI. Okay, so what I'm talking about is this web app that we have here is essentially you see that this is a web app that we have built. In this, there are templates for HTML and all. This is the images and other things. And this is the environment that we have created. This is the entry point. And this is the auto-generated file. We can delete it. And here, this is the helper, which essentially does the main job. Okay, using cat, we can see what's inside it. If you see, this is the guy who is loading the model. You can see that this is the code that is loading the model. And this is here, it's resizing it. And then here it is pre-processing, and here it's predicting. So what we are doing is we are giving an image, we are giving it to the neural network, and neural network is telling us, what is the neural network is telling us what exactly is uh, how much neural network is telling us that what is there inside it. Okay, so to understand about neural networks, do take a couple of you should watch the one session that I have done, backpropagation from scratch. They'll give you a very clarity of thought in terms of exactly how neural network functions. So this web app is basically loading an existing pre-trained model, and then once it has got the predictions, it is returning those predictions. So this is the intelligent part of this web app helper underscore py. So this is what we did last time, and I wanted to give you an overview. So let's launch the things that we built last time. So this is something that when you're building a Flask web app, this entry point is what you create. You see this? So from here, from this line onwards, this is where we are creating a web application. What this web application does is it maps that when people are calling slash, like top level file, what top level URL, what is going to do here? It's going to call the index, and then here it's going to it's going to upload the file. So whenever somebody is calling slash uploader and submitting the image to it, it's going to call this function. Okay, and here we are handling that file, and we are saving it to a path, and then we are calling here that method that we have created previously here, get classes method. Okay, so we are calling that one, and it's getting predictions, and then we are returning it to the user. Okay, so those who are curious about finding out how much time it takes, they can place like either here, from here to here. they can place a timestamp, or they can print the time taken. Okay, there is okay, print time, or you can say print, okay, calculate time span. Okay, you might be laughing that I'm searching for such a simple thing, but that's the truth about coding, that you do not memorize many things. You just do that. So right, so this is the current time, and this is the previous time, and right, so okay, so this is good. All right, and you can use this. All right, so I'm going to just open my notes, and so I can just say this is my previous time, wait for some time, and then I'm going to do this, and I'm going to print. That's it. So I'll say total time taken. All right. Yes. All right. So let me just take this and put it in my web app and then observe how much time it takes. Okay. That's the first question that somebody asked me. Okay. So I'm going to just pick my app underscore helper. Okay. If you're not comfortable with the console and you're not comfortable with VI, all right. Okay, so yes, I forgot to import, so I'll just import this. Okay. All right, this is way better. Okay, this is going to be the one. All right, which one is my app? This one is the app that we are dealing with, and I'm going here. So let's see. Let's see. So here we are saying, start the. All right. I just hope that it works. All right. If it doesn't work, we'll just say start. Okay. And here are the predictions. All right. Towards the end, we'll just say, all right. And we'll say total time taken. Okay. We'll say start minus end, sorry, end minus start, and minus start, and total seconds. We are calling the function on that. Or we can just write span equals. Perfect. Okay, so there we go. So this is okay. Those who are wondering whether it'll be useful or not in your life, trust me, no matter you are a data scientist, you are a research engineer, you are a mechanical engineer, everybody has to make at least one website in their life. Okay. So, so it's important to know what goes on in a web app, and trust me, it takes time to figure it out. So here we go. Let's see if it works. All right. Let's see. Does it say, it says invalid syntax because I said from. All right. Let's try again. I put something else here. I put 2 equals. Never mind. So the copy pasting is not that easy at the end of the day. Yes. Thank you, Peter. All right, looks like it seems to do something. Let's test it out. Okay, so what was the port again on which we were running it? To see that port, just go here and click on app.py. All right, so it's running on 4100 and my host name is E. All right, so we are saying e.cloudxlab.com. Yeah, those who are wondering where did I get this idea that it's running in E, you see E here, e.cloudxlab. For you, it could be F, it could be G or something. Okay, and this is the port. Every web application works at a port. Now, if you just pick something and ask it to recognize, okay, so let me try to pick it. All right, so what is exactly, let me just change the photos to icons. All right, it's going to take a lot of time. Okay, so let's see, let's try this one. Will it work? All right, okay, so let me just give my photo and let's observe what's going on there, right? So what's going on the console? Okay, so here we go. You see, time taken. Do you see anywhere that it shows time taken thing? Not yet. Okay. Total time taken. Do you see that? Total time taken is 12 seconds. Yes? So it took 12 seconds to do this thing. Now, see another time, we'll again pick the same image. Okay. And or let's just, yeah, let's just pick the same image and observe what happens. Okay. Okay. I don't know what all it has predicted, but let it be. Okay. Stool. Oh, stool is that. Okay. All right. Let's just observe how much time it's taking. So there's a web app. Imagine like this. So there is a web app, and we are using that web app to do this. Do you see that? It is 11.49 seconds. Sounds crazy to all, right? Yes. This is not at all, you know, scalable. What does it mean by scalable? Something that is catering to one user, how will it cater to 1,000 users? And that's what matters when you are, okay? Okay, so yeah. So essentially the main idea is, the main idea is uh, to improve this performance. Okay, so this is not at all scalable, because more number of users will take more number of time, and every time they are coming, it's taking this much time, and therefore 12 seconds of processing or computing is just too much. Okay, imagine 1,000 users coming to your server. You will require 1,000 parallel machines to do it. Okay, because I mean, when one machine is not sufficient for this, how will it be? One of the common things would be that, hey, I am really sick of CPUs. Let me try to do something else. Okay, now let me buy a big computer and make it fast. It won't make it fast. Okay, it won't make it fast, because the time, let me just show you where exactly time is going here. Okay, the time is essentially, let me just pick this. Okay, pick this. So here we are creating the model, right? So total time taken. Okay, total time for loading model, right? Or we could just say this minus start. Okay, and we'll just start it again. All right, now we'll say here uh, total time to do predictions. Okay, total time for predict. Okay, so what we have done is we have okay, let me just move it down. All right. So now it'll predict, tell us like how much time is taking to load the model and how much time is taking to predict. Okay. So let's just see if it making sense. It is making sense or not. And go back to here. Okay. All right. There we go. All right. It seems that it has started something. And there we, let me just choose the same file so that there is no difference between one to another. Okay. So all right. And in real life, when you join a company as an engineer, these are the kind of challenges that you will have to face. That here is an app which is taking too much time. Can you improve it? And that's something that, like one of the projects I had in my past. Okay, let me just do it again. I think it printed. It worked. So let me just see if it worked or not. All right, going back here. So let me go up, 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 up. Let me do it again. Okay, here you can see, right? All right. So here is the answer. All right. So you can see that where did the time go? In loading the model. You see that? Total time taken for loading the model is 11.12 seconds. And total time for prediction is hardly 1 second. Okay. Therefore, you can, if you can reduce this, your overall time will come down drastically. It'll come down drastically. Okay. So what we're going to do is we are going to keep this model ready and then we do the predictions. All right. So only this would be only one-time job whereby it'll be ready for us. And now very important thing that you should notice that my question to all of you is this model different for different users? The answer is no. This model is same for all the users because it's a pre-trained model, and 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 basically this model, once it's loaded in the memory, it can cater to all the users. So essentially, if you got 1 million users, so for all of them, you will save this 11 seconds, right? You will save this 11 seconds. Now, coming back to it, this part, the predict part, is something that we require in production. I'll come back to it. How would you reduce this further? I'll focus on that part. First, let's remove this part. Every time the request is coming, model is being loaded, and the stuff is happening, right? So, so if in Java, guys, those who are from Java background, what they would do usually is, right, they will create this as a static. They will create the model as static. Even those who are coming from C, they will create it like a static, right? Static is something that remains in the memory until that virtual machine is killed. But that's not a great practice. So what people do is they put it in cache. But here, the problem is that if you put it in cache, still it is in the memory form, like in a sequence, like an array form. You have to construct the model. Instead, keep the model ready as a service. Okay? Keep the model ready as a service and let the service answer to everybody. So the simple answer to this is that okay. So what we are going to do is, so this is the model. So there is an image. So this is the input of the image that is coming from the user. Web app is loading the neural network, then doing the prediction and returning. And it's also returning the classes. Now, the idea is we take out this load neural network part and put it on another computer. So what we're going to do is we are going to create another computer, okay, another process. Okay, we call the service. Okay, and this guy will be ready with the neural network. It'll do the load neural network only once, and many web apps, like many calls, will basically talk to the same same model. Okay, so essentially, it is completely okay to launch this as common for all the people in your organization, not only for this web app, but for other people as well. Therefore, it is a good practice to convert. It's a good practice to convert. It's a good practice to convert every model which is of wide use into a service. So this is like breaking a big web app which was doing everything into two parts. One is like service and other is the web app. So this is the first part and this is the second part. So we split it. Okay, we split it because this service part, basically the neural network, pre-trained neural network, is common for all. Is common for all, right? Now, the other beauty about it is this: web application has got a different scaling pattern. Scaling pattern as in, web application will take some amount of resources, right? Therefore, maybe for 1,000 users, you need to have, let's say, 10 web applications, right? Separately. While for neural network, maybe for 1,000 users, you just need two. Okay. So both of them, the web app and the neural network service, both of them have got will get parallel, or you can say independent scaling pattern. Okay, so you will be able to have this, modular flexibility, that as more users are coming to, more requests are coming to this service, keep on scaling it, keep on increasing these machines, and it'll keep on scaling at its own pattern. Similarly, this part also will keep on scaling its own way, or you will basically scale it. You will have this luxury of choice, that that I can, based on the load on my web application, I will scale it in certain pattern, while the neural network, I'll scale it in different pattern, because your neural network could be used by multiple different web apps. Okay, so this was a very neat or a simple hack that, and it's actually very useful also, because people who build the neural networks are different people, usually in the company, and people who are building the web app are different teams. So therefore, this making it a service makes solves multiple problems. First one, the speed problem. Second one, scaling problem. Third one is the team organization part. All right. So the most logical part right now is to break the web app. We call that monolith. Monolith is something like made out of single stone, which is doing everything. That's what is called monolith. And we're breaking it into multiple parts, and we are making it, modular. Okay, we are splitting it. Therefore, both of all these parts are working together. Yeah, yes, and yet they are independent. Perfect. So this is what we are going to do. We had a monolith app that we built last time. We are going to split it and make it two. All right, let's jump in. Okay, so we are done with it. We are done with it, and we are done with it. Okay. All right. Somebody was asking me that, right, that in an interview, I'm not allowed to use the Google search, and therefore it impacts my confidence. Okay. To be honest, if if in an interview somebody asked me that, hey, do you know how to use time in Python? I would say no. I have written like whole virtual machine, my whole web server, not web application, web server, just like Flask in Java, and I still do not know how to use time. And to be honest, time is a complex thing. If you take a look at the libraries from various languages, especially Java, notice how many versions of that library have been there. So time library has gone probably like 7 revamps in Java, and still they couldn't get it right. And same is in other languages. So it is completely okay to say to the interviewer that, hey, I do not know exact API, but I can just, hypothesize that this is my API. Okay. And if somebody is bent on, you must know this particular function, I would say sorry, right? The basic things like knowing how to address an element in an array, how to write a for loop, while loop, all of these are all okay. Those things you need to know. Okay. All right. So moving ahead, and here we go. All right. So those who are asking about the certificate and all, don't worry about the certificate. Trust me. When I'm hiring, I'm basically interviewing. I hardly take a look at people's resumes as well. Okay. So yes. Yes, the other question, is it transfer learning? Of course, it's a transfer learning. Transfer learning, essentially somebody prepared the model, we are using it right now. Okay. So the most important part is that we should know how to build a model. Perfect. So we built this model, and this app we are not deleting right now. I'm just deactivating the environment. I'll reactivate it soon and closing this window. Going back to the today's project. So this was a recap. I know that it has taken 1 hour, but I hope whatever we discussed was useful to all of you. And okay, so it's going to be really, really important. And it's good that we kept a time. One very important thing to do is, very important thing, whenever you are asked, okay, whenever you are asked to improve a performance of a system, always make a note of existing system. What is the performance of existing system? And that's the first thing that we have done. So this is our existing system. We broke the system down into parts, as in we broke the timing into parts, and we noted that total time taken for loading the model was this much, and total time taken to predict image is this much. Therefore, now we are all set to move ahead. So whether you are optimizing SQL queries, whether you are optimizing team performance, whether you are optimizing physical performance, thumb rule is make note of time. Anything that is not measured never improves. Okay. And you yourself will get frustrated if you do not measure time. At every step, measure the performance in terms of time and the accuracy or whatever criteria you have, and then you move ahead. Perfect. So moving on. So we've already deployed this project, and this is what is going on. And here we are creating the same thing. I think we have all, okay. Yeah, one more thing I forgot to tell all of you, that there is a beautiful command called time. Okay, beautiful command called time. Time tells us how much time does each part take. Okay, so you can create whatever we did earlier. You can create this kind of a file and run it through time. Okay, time command is a Unix command. It's a beautiful command. It tells us how much time it takes. Okay, so you can try this out. I'm not going to do this right now, or if you want, I can do this. Okay, so all right, let me just do it. Okay, and let me also activate the environment. Okay, where is the environment? The environment name is img this bin activate. Okay, so I'm saying that I'm going to create this file. This time I'm using vi. Vi is a text editor that you will find usually in terminals, like black and white terminals. This is quite useful, and it's kind of de facto standard. Okay, now let me just test this is exactly what we did earlier, and let's see what happens. Okay, so here this is exactly what we did earlier, and we are essentially using this to measure the time. Time is a very cool command, and we use it very often. All right, looks doing something. Let's hope that it works. So you can see this time right now is taking 32 seconds, probably. Okay, so never mind. Now, moving ahead, we are done with this. Okay, or should I click on that button? It gives me a good feeling of accomplishment. Nice. It checks the whether you have created it or not. Okay, so we made a note of the time taken, and it's a monolith program, but no, there's no flexibility. I've written whatever I've talked about, I've written it here. Okay, and this is important for all. Um, all right. Okay, so we started at 8 o'clock, and yeah. So what we did was we basically did a recap. We tried to launch the thing that we built earlier, and then we basically made it a little more. If we observe the time taken for this model. Now, why I'm talking about this, why I'm taking so much time, that I have taken so much time is why I'm taking so much time to do this is that um, even my engineers who I was explaining this part about monolith, it took them quite some time. And same thing I observed at Amazon, all my engineers, when we were basically building an optimization pipeline for the image, that the big image that you see the product of the product. There again, when we were optimizing that pipeline to bring down the speed, like time taken to by around 10 times, like 8 to 9 times. Okay, so you can say 10 times. So that when we were bringing down that one, so it took a long time for me to explain that why it'll improve. Okay, so the most important thing to do in anything that you are doing, observe what is taking time. Make a note of it. Put everywhere the statement, the one that we saw, the time statements, and then observe it and make a note of it. Now, your half of the problem is done. Okay. And moving ahead. So that's what we have done. Now, what we are going to do is we are going to create a service in a a software piece called ZMQ, Zero MQ. Okay, Zero MQ is a very interesting piece of software. Okay, and those who are not aware about it, Zero MQ is essentially a small, very tiny library that can convert your program into a service. Similar, it can do many things. It can do wonderful things. And the more I studied about it, I was like amazed what all you could do with it. And there is a like really tiny and highly efficient system. So out of all the, I mean, I have used multiple RabbitMQ. I have used the other services framework, the Jersey and others, but I found Zero MQ to be extremely efficient. Okay. Okay. So what we're going to do is the second part that I was talking about. Second part. Um, yeah. This part, the neural network part. This second part. The second part this is going to be in Zero MQ. This is going to be in Zero MQ. Okay, this is going to be in Flask. Okay, and why Zero MQ? Because I find it very efficient, and usually when it comes to doing things in Zero MQ, uh, I found the performance to be great, and it is fairly scalable. Okay, so moving ahead. Now here, you should take a look at Zero MQ. I'm a big fan of this piece of software. And yeah, so I mean, the one thing that you should take a look at is their use case tutorials, and you should take a look at how to use Zero MQ. And all right, and it is written in multiple languages, and the one that is there is like the C is essentially the one that is really popular. And what about Python? Right, Python is also 100%. Okay, so coming back to it, so you can use this. Now I was saying, yeah. Now, take a look at this guide. It is essentially something super cool. I'm really, really impressed by the way they have designed the system. And there are patterns like how to build this, how to create this, how to do that. All kinds of pattern you can take a look at a single place. Okay. So, right. And as part of software engineering, 90% of task is to understand somebody's library. And this will be worth your time. Trust me. Okay, this is worth your time. And all right, so basically it is just go through it and you will get an idea. So there are many things like publisher, subscriber, those kind of things you can build. Zero MQ is usually considered as a pipelining software in which it creates a queue. There is a producer, there is a consumer, but using zero MQ, you can also create a service, really, really efficient service. Okay. Some of you might question me that why are you using zero MQ? There is one is efficiency. Second is it's completely modular and it's open source. And right now the some might say that why not Flask, why not this, why not that. I would say that you should try all of that. Okay, you can try. Okay, whatever gives you great results, anything that can hold our model in the memory across multiple requests should be sufficient. If something is not able to hold your object in the memory across the request, then it won't be of any use. Okay, what we want to do is we want to create this kind of model. When user comes, they'll come to the web server, which is in Flask. Then this Flask server will give a call to our GMQ server. GMQ server will call a worker. This guy will get the initialized model and then use it. And as more and more users keep on coming, it'll keep on creating worker, but the model will be shared across the workers. Therefore, for every worker, the guy who is going to do the prediction is not going to be, it's not going to consume too much of, uh, it's not going to do the loading part. This part, every time a worker is spawned, only this time will be taken, while this one will be only done once when we launch the model server. Okay, so there is now that there's a web server, there's a model server. Okay, and this is the step. So user uploads an image, it goes to this web server. Web server makes a request to the model server. Model server creates a worker. Worker does the predict, and it yields the classes. And zero MQ, this one gives the classes back to the Flask server, and it goes to user. Now, this sounds crazy, but this is your going to be the first lesson in the architecture. Break down the system into parts depending upon the use case. Okay, so we built a monolithic server previously, and now we are building it, in parts. Okay. By the way, this is all free for everybody. So let me just copy the link and post it here, so you guys can learn by yourself. So this is how you can again visualize. So Flask server calling model server calling this, and so on. So whatever I discussed, it is mentioned here. Okay. So it's important for the people who have not worked with services, who have not designed the systems before. And the other thing is that here, the most important part to understand is we are not doing it because somebody told us to do. We are not doing it because some senior manager told us that, hey, use the service-oriented architecture. No, we are doing it because it's needed, needed for the user. It's not our whims and fancies that, okay, zero MQ is a cool thing, service-oriented architecture is cool thing, so we are creating services. No, we're doing it from the perspective of solving a problem. Okay, we are taking a decision, and that taking a decision is the ability that an engineer develops over a period of time. Okay, when you build more things, when you learn more things. All right. So yeah, so we are going to create these two folders. Okay. So there are going to be now two folders in the same top folder. First, we'll create this folder. Inside this, this is going to be, let me just draw things. Okay. So this is going to be one server. Okay. This is going to be called model server. And this will run in 0MQ. Okay. Let me just put it like this, 0MQ. This is going to be Flask. Okay. So we are going to create two separate systems. And all right. So perfect. Now, uh, right, this is going to be the separate environment. This is one environment, this is another. Notice that somebody asked, right, this could be in C, this could be in Python, right, this could be in PHP, right, this could be in so many other different languages. It could be in C#, it could be in Rust, it could be in so many different environments. So essentially, when you break it into two parts, suddenly you have flexibility, modularity. Okay. And a simple change in our design led to so many different so many advantages. Okay. So this one could be in one language, this one could be in another language, and that's how most of the systems, the complex systems at Amazon or any service, they are written in different languages. One part I was working, on one hand, I was working with not Python, I was working with Java in Amazon, and other part was written in Perl. So the whole app was being served by Perl as well as by by so one part was written in C, and other not C, Perl, and other was in Java, and they were all working fine. And even today, the website, half of it will be rendered by Perl and half of it will be rendered by Java, and so on. So there's a beauty about the software architectures, and this will be your first lesson in software architectures. And don't try to memorize the architectures, it has no use. If you just walk through what we are doing right now, that should be sufficient to open up your mind. Okay. And all right, so we're going to create this structure. Never worry, let's move ahead. There are 10 more steps. So we are going to, right, I'm just deactivating my full old environment. Done. Now moving to like home directory, cd home directory. Tilde is same as cd empty. And we have also deactivated. Now we're going to create a directory named this. All right, it's not a big deal. Okay. And right, we are going to go to this folder. So this is going to be the main folder. All right. So that's it. Okay. So we are going to do the first part. Okay. We are going to do the first part. Create a directory named model server folder. Okay. Model server folder. And also create Flask server folder. So these are the two servers we are going to create. And inside this, fine, we are done. Now switch to this one. Okay, you take your time to read it. Okay, this is something that is very important. All right, this is real. It's not a toy, it's a real something that happens in large companies, something that you will build if you join Uber, Amazon, Google, or anywhere. And this is a real engineering. Okay, because I was watching somebody's videos on scaling, and they started suddenly talking about Zookeeper, and I was wondering how could we use Zookeeper in that. And looks like to me that video was done by somebody who has never worked somewhere. So it was funny to um, see that part. That I mean, that's one of the reasons why I started this in first place, because most of us were wondering like, how come we are not getting great engineers from the market. At Amazon, it was very difficult for us to get really good engineers. We had to spend a lot of time to train people into senior engineering. And yeah, it took like 3 years or so to make somebody do a little bit bigger projects than Hello Worlds, and that's why. Okay, so all right. I think we don't have to do anything here, do we? Let me just check. This is markets completed, so maybe I have nothing to do here. Okay, let me see if it works. Okay, this one is working. There is nothing much to do here. Okay, and now if we have a virtual environment, this, how do we activate this environment? You answer the question. I'm not going to answer this. Otherwise, you will just copy paste. All right. So, okay. Now, here we are creating our virtual environment, and then we are activating it. This is going to take, again, a bit of time. So let's move ahead. All right. So where did I create it? All right. I think I've done it right. Okay. Yeah. Okay. So I'm at step number 3. Now, one more thing that you would notice is that when you are designing a software, okay, now, one a very important part that I would like to tell you is that when you are building a software, right? So at every point of time, make sure that activate sorry, you do pip freeze, because whatever you're installing, to get the list of it, you put it in requirements, and then you can use those requirements as is. Okay, so all right, now we have activated this model environment. We are saying pip freeze. Okay, and we are installing 0MQ. Okay, 0MQ. Then we are installing all these parts. Oh, we could actually copy that model, right? Yes. Oh my, this is going to take a lot of time. All right. I hope it doesn't hurt badly. Now notice that, okay, so between 0MQ environment and Flask environment, where should we need TensorFlow? Anybody? We have two applications right now. One is Flask, other is 0MQ. Now, which one of these, Flask or 0MQ, which one will have TensorFlow? Both or only one of them? 0MQ and, sorry, Flask and 0MQ. Tell me. So we talked about this architecture, right? So while this thing is happening, I'll just quiz you. My architecture is gone. Yeah, here. So you can see here, right? So this or this, which one will have, this is a Flask and this is 0MQ. 0MQ, that's right. Thank you. Ashutosh, Peter, that's correct. Okay, wonderful, wonderful. And yes, it's going to be the 0MQ. Okay, now the important part is not both. Okay, because the web website doesn't require TensorFlow, right? Because the entire overhead is on 0MQ now. Okay, for web app, that's a service, that's an API call that I'm calling. Just like you make a call to AWS, similarly, our web app is making call to our 0MQ service. Okay, avoid doing it both. It's not really needed. Okay. All right. All right. So let it finish. Let it finish. It's going to take forever. In the meantime, can I do something else? Okay. Now saying create the ResNet model server.py. Okay. While it's doing that, I'm going to create in this folder model server and copy paste this code into it. Okay. I'm going to copy paste this code into this. All right. So go to files. While the process is going on there, I'm going to go to Flask. Yeah, this one. This is the one. I'm going into model server and I'm creating a file here. Okay. And here we go. What was the name of the, no. All right. What was the name of the file? The name of the file is, if you follow this one, it basically is sufficient. I'll walk you through the code. So right now we are creating a program that will be executed by 0MQ when somebody calls the server. Okay. So here, this is the piece of code that's essentially doing the job. So you can see that on the 0MQ side also, we are first creating a TensorFlow session. Then notice that this is in older version of TensorFlow, because that's what seemed to work great here. And then what we saw was that here we are initializing the model. Notice that this is like in the beginning. Okay. And then here, this is the server. Okay. What you're doing is you are handling start, stop, and it's basically a thread and it's running here. And here there is a request handler. So we are basically creating a full-fledged service using 0MQ. So whenever user will call them, so first of all, the server will start when we run this program. And the server, when it starts this server, right? And when people are asking for the request, it's going to, here, as soon as we launch this server, it's going to listen on this internal port. Okay. This is an internal port, and it will listen, it will keep on polling this port and will answer. This is really raw in the sense that it is essentially TCP IP. Okay. And right, and here as soon as users are right, there is a message at a particular port, it is going to create a request handler. So this one actually tells you that if you have to write a web application tomorrow, your own server, you can actually use this pattern. This is really, really cool. Okay. So this is again from the 0MQ examples that I've taken, which actually works pretty well. And in this particular function, you can see that whenever users are calling it, it's essentially calling the model here. Okay. So this part does the prediction and loads the model. So this ResNet basically is being loaded here. Perfect. Now, in the meantime, I hope that the console has finished the work. Oh my, it is still stuck. All right. By the time, I think it will finish the entire thing. Okay. All right. All right. Okay, so here I've described the code. So let me walk you through the code again. So this is basically common that we are importing various things from TensorFlow, various things from like image processing tools, the threads, the 0MQ, the base64 encode, and NumPy. NumPy is basically a numeric array in Python. And this here we are loading the model. Okay, so we could also put this here inside the thread, but it's okay to put it here. Okay, inside the constructor of the thread. So this one is the server that we are creating. As soon as the request will come, it's going to call the request handler, create a new instance of request handler, and handle the request. Inside the request, you'll see the process method. That's what does the processing. Okay, and so on. Okay, so this will call run will call process. Okay, so like that. And that's pretty much about this. Okay, and the way we are going to communicate is in the form of JSON object. Okay, so web app, the Flask server will send the JSON object to the JSON object to the 0MQ. All right, so that's what is going to happen here. And fantastic, now it's done. I'm going one step back and just finishing the remaining part because it was taking time, so I moved ahead. All right, this should not take much time. And once I'm done, I'll just freeze the requirement. Freeze the requirement as in, like if you do pip freeze, it'll print all the things that you have installed with the versions, and you save it in a file called requirement.freeze. Okay, requirement.txt. And whenever you need to just install anything, you just say, I mean, the whole environment in a single shot, you'll be able to install it. Okay. All right. So you can see, yeah. See, it installed quickly because everything is already installed, so you don't need to worry about it. All right. So if you see the things that we have already installed are saved here. All of these things we have just installed in this environment. So in the production environment, you don't have to worry about anything. You just have to create an environment and then do pip install inside that with the requirement file. And that's it. Okay, and do commit this requirement.txt into your code base so that in the production environment, people can quickly recreate the environment. You don't need to commit the environment as such to the source code repository. Like environment is stored here, right? This model env. You don't need to commit it into the repository because this one contains like system specific things. Instead, commit this and this. Okay, right? Those who are new to Git, do go through our chapter on Git. It is again free, and you can just go into CloudxLab and try it. Okay, so yes, so we are done with that. Now everything else is going to be really cool and fast. Okay, sorry to not take breaks. And all right. Okay, so yes, so we are done with these two steps. So our code seems to be, we are all set, right? Do go through these lines of code. Try to understand it. Even if you don't understand it, it's completely okay. And you just move ahead. Okay, because once you understand each part, what exactly each part is doing, that's good enough. Remaining part you can copy paste and make it work. All right, so coming back to it, now we are going to create a dummy client. Okay, this is again very important thumb rule of life, that when you have disconnected systems like system A and system B, make sure that you have dummy test cases or dummy clients for all of them, so that you don't need to always go through the server in order to test your service. Okay, so we're going to just quickly create a file. Okay, I'm just going to create this. All right, and I can again go here with something that is quick, and I'm just saying new text file, and I'll just change the name of the file. Okay, perfect. So here is the dummy client. What's going to do is it's going to create a JSON object. Okay, and put the image, convert the image into base 64 and put it inside JSON. And then whatever we get as an image string, the whole JSON object, we will send it, we will create a client to like 0MQ and send it to that socket. Okay, and then we'll wait for the response. And once we get the response, and we are going to print it here. All right, so here we are calling this function that we have created here. In the main method of our Python program, we're calling it with this image of the dog. Okay, you can take a look at it using the using the Jupyter Notebook. You can open Jupyter Notebook parallelly going to the MyLab. All right. So coming back to it, we have created this file and we can test. We can, first of all, we have to run in one of the terminals. In one of the terminals, we will have to run RESTnet, right? So here we are launching our model server. Okay, this is the model server we are launching, which is going to be on the 0MQ. It'll wait till the client comes, and when the client basically sends it the object, it will return the meaning of it. Okay, so here I'm basically going to open one more, one more terminal. So I can go to MyLab/MyDeskLab and then click on Jupyter. Okay. So now you'll see that, right, there are two environments. One is on the right-hand side, right? And other is without anything, right? It's the same thing, don't worry. And this is the one that we are dealing with right now. Okay. This is the model server that we are dealing with right now. This is the file that we've created. So we can create, here, we can create a terminal. Okay. The good part is that all of the work is persisted and at a same central place. So you don't have to worry too much about, where is my work. Okay. Now coming here, right now we are in this directory. So we are going to be going to this and then going to model server. And here there is one test client, but before that we have to activate the environment. Okay. And of course, here you can see we can just run Python and this. Okay. You can see that it has, given the result. In case you're wondering what exactly is going on here, I'll copy this file, the one that we have written in the test client. The test client is this. This is the file that we are talking about. Let me just copy this to my home directory here. Okay, and go back to this folder. There you'll see dog.png. Okay, so this is my input that we are feeding here. Okay, so all right, now wonderful. So basically the test client worked. Okay, now let me just see the time taken by the test client. Okay, all right, Python test client. Now you see the time. You see the time. How much time does it take? You can see. Are you happy with this? Yes. Now the time it takes is 0.28 seconds, right? Because the model loading has finished while we launched the server. Here, when we launched the server, it is started this. And don't worry, because here, this is the JSON object that we are sending. Okay, so what you see is that now if you keep running, do you see the difference? 12 seconds to 0.6 seconds. Okay, 0.2 seconds actually, if you see. Now this is engineering. Okay, this is engineering. This gets you really good results. Okay, now rather than calling it from the test client, we will call it from the web server, and that's pretty much. And that would solve big troubles. And trust me, this was one of the very important lessons that I mean I learned in my career in long back, that if the performance is not great, everything is just useless. Okay, so I was trying to build a face recognition system, and when we saw this, we said, okay, 12 seconds. And other persons had told me that, oh, it's not possible to do it real time because it takes 12 seconds, right? And I said, there should be a way to optimize it. And we figured it out that it is possible to do it in 0.2 seconds, which is near real time. Okay. And those who are wondering that if you want to do further, more better work on the optimization, they should take a look at the face points. There are various models that I'm going to publish recently, in probably recent time that we are working. I was experimenting on, where like it happens in the browser. So coming back to the very important point, By cleverly architecting our program, we brought the time taken from 12 seconds to zero point 0.2 seconds. Okay, 12 seconds to zero point 0.2 seconds. All right, so it is around 60 times. So 60 times improvements is actually converting something, a project that was impossible, to something that is very much possible. All right, so that defines the impossibility and the possibility. Okay, perfect. Now moving ahead, so now this is where we are describing what's going on. I think yes. All right, in your free time you must go through these steps, read through it. Trust me, you're going to learn a lot. Okay, you're going to learn a lot. And right, in order to kill it, you can just either press Control C. Usually Control C doesn't work, so you have to do PS and the 0MQ, because handle we did not handle the Control C in our server. You can actually design a 0MQ service which can handle the which can handle basically. So I'm just trying to see where is my process. Okay, so I have to find out this Python process using ps-u. This is my process, and I'm going to kill it. The way you kill in Unix is say kill minus m this, right? Now, if you go back there, you'll see, oh, it has been killed. So I went to another terminal, killed the service, and that's it. Okay, so this is a very, very important part about the process. Okay, and again, now, what you can do is you can go to now, let's create the Flask server now. Okay, we'll just deactivate the environment. Okay, deactivate the environment and then go to this folder. And I'm just copying what I did yesterday. Those who are wondering what does rsync do, rsync essentially helps you in synchronizing the files really fast. Right, one of the things that I learned very early was this rsync algorithm. It is just amazing, and if you have free time, do take a look at the rsync paper. It's actually pretty good tool to synchronize. In case you have a folder in which you have a music and you have to copy the files every day, you can just do rsync. Similarly, if you have like database right on a remote server, and every day you have to take a backup, you can do rsync, and rsync will only transfer the new change, right? And that's the beauty about rsync. So it'll only transfer the new change that has happened without keeping track of till what a point of time did you back up yesterday. It'll just compare the two folder structures and copy it. And that's the beauty about it. Okay, and you can see that it's really fast. So instead of doing RCP, I prefer rsync because it is a very seamless way of copying. All right, now I've copied the the previous project, went to this folder, and then we have already okay, we are not copying the environment. Okay, and now notice that we are not going to install the the TensorFlow or anything in the Flask application. We're just going to install the Flask, the Flask web app, web server, and then we are going to install 0MQ, and that's pretty much. Okay, what happened to this guy? Okay, oh, I did not activate, sorry. Okay, I did not activate it. I have to activate it first. So I'll just activate it. And there I go. And I'm installing it now. And then I'm going to do pip freeze. Wonderful. So this is, while this is installing, okay, it should not take much time. It should be really fast. And that's the beauty about most of these servers. They are really fast. All right, so this is the web application. Now we're going to, right? So we are going to modify the app, the app that we built last time, and we are going to delete the old one. Okay, why it's opening again and again. Uh, okay, so here we go. So we go to this folder, this folder, Flask server. Okay, all right. So I went to this folder where we had this Flask, right? We have just copied this whole thing from the previous project, and now we are all set. We have all these things already in the place. Now, what we have changed is, one is Flask environment that we have created. We basically did not need TensorFlow and other things. Second is we are going to change the entry point. Okay, we are going to change the entry point, and we're going to create app.py. Okay, and right, convert it into the editing mode. In this is the text editor in Unix. All right, so go through it, and you can actually create it using the Jupyter also. Now, once you are done with it, you can just run the program. All right, do go through this code. Okay, maybe you won't understand in the beginning, but rest it'll be all okay. Okay, now since I am on e server. Okay, I'm just closing this. I'm on e.cloudxlab, so I can just open e.cloudxlab.com. What was the port number for me? I think it is 41 something, right? It is 4114. 4114. Okay. Now, before we launch this, remember we have to launch the other server also, correct? So we are going to go to like close this, go to this console. So we have two consoles open, One is to run, the model environment, the model server. And how do you do that? We just run this program. That's it. So it'll launch the model server. Now, in this environment, we are launching the Flask server. So we have two servers running, and the client is the web browser. The client is this. Okay. Now we are going to just take any object. Say, what was the object last time we took? All right. All right. Okay, so you can see that the significant difference that you will get by this now. Okay. You see this? It's near real time. All right. All right. So wonderful. So that's pretty much, and it's actually near real time, and you can now kill it. That it won't allow. Okay. For me, better is to do Control Z. Control Z sends it in the background, and I'll say kill -9 process ID. Okay. So that's pretty much, and is it checking that whether I'm running the service or not? All right, everyone. So I hope my voice is clear. My network went kaput for a moment, and it is still really, really bad at the thing. All right. Hi, everyone. So I hope my voice is coming through fine. Please respond quickly. Um, okay. So, all right. So, hi, everyone. So I hope my voice is coming through fine. Wonderful. So, thank you, everyone. Please let me walk you through what all do we offer at CloudxLab before you go away. So, do go through our courses at CloudxLab. So this was a successful webinar. So we were able to build this. Do go through this, and I mean, you will be able to learn multiple things in this project. Okay. Now, quickly, how do you access this? You go to CloudxLab and click on Explore Courses. There, you can just search for Flask, and you will be able to get it. Also, take a look at the courses that we're offering. The courses that we are offering are really, really useful to people, and do enroll for the courses or the lab, and this will definitely help in your career. All right. So this is something that we are working on it, and there are a couple of more questions. So if you don't mind, I'll just take those questions. And yeah, here we go. Yes. So a question was, why did you leave Amazon, and how did you gather courage after failure to start up again? Did failure break you enough? On how many failure can you go through before entering the road? All right. So it's a hard question, and it's very interesting one. All right. So I left Amazon because there was just too much of travel, and I really wanted to start this. And I saw that there is a huge opportunity in this, and there is a need of people looking to learn, and there's a serious gap in the talent as well as the need of the companies. Therefore, I started this. And with respect to right, the failure, I do not consider most of the things as failure, right? Whatever happens, right? So if you learn from something, it's not a failure. You can just move on. Okay. So either you're learning or you're succeeding. All right. The most important thing I would say to all of you, that without trying, nothing is going to happen. So, I mean, until you try, you won't be able to figure it out. But take a safety consideration based on your dependencies, your dependent, and so on. I mean, based on that, only take the plunge. And for me, it was interesting to. I mean, I have. Started earlier, have taken the company to some level, and then I joined a job and then went back. And it's completely okay to, go back to job, or go back to job. It's completely okay. All right. So, and right, and it's only with the failures that you learn and you become a strong person, right? The With respect to success, you kind of become very, very when you got one success, you might be lucky, but I mean that would basically make you very complacent at times. And yes, for me, I have never worried about job. I had been lucky to get really good job in the beginning of my career, but I was also, worried person who just left the job and started earlier and then again. So it's completely okay, and as long as you are in the safety net, uh, like if you do bungee jumping and you do not take safety precautions, then bungee jumping is not fun. Okay, if you get hurt yourself, that's not fun. Therefore, take your precautions and then play around. Okay, so that'll be my way of taking it up. It's a good important question, and then we all struggle with it. Okay, so my suggestion is that if you are planning to start up, whatever you consider as safe, take that one and then you start. All right. I mean, either extremes are not very fruitful. Okay, so and doing a job is also not a good option. I have always enjoyed my journey at jobs. Like I was at D Shaw, we did wonderful things. I was at Amazon and we did wonderful things. And the most important part is no matter what you do, whether you do job or you do the startup, put your heart into it and you will enjoy the journey. At Amazon, no matter what kind of work I got, we converted into super interesting. And that's something that you all would learn. So, how you do your work is up to you. Either you do it with a sad face or with a happy face. I mean, it is up to you. My suggestion will be do it with a happy face. More ideas will come to you. Your learning will be better, and you will succeed to a greater height. And that's one thing that I have learned in one of my career. I mean, I want to. This is a very close subject to close thing to my heart. That no matter what you do it with your full energy, with full smile, with full happiness, with the mindset that even if the work is extremely boring, you are going to make it really, really good. So in one of the companies I worked with, I do not want to take a name. It one of the companies that I worked with, there was this very dirty project. Nobody wanted to touch it, and and I was asked to fix a couple of bugs in it. Okay, and I looked at the project. I thought about it for a couple of days, looked at the code, tried to understand what's going on, and tried to look at the history of the project and try to understand what is the overall objective that we are trying to achieve. And then was able to figure out that if this project is rewritten, it will improve the performance by magnitudes, like many number of times, the way we shifted. So suddenly when I proposed the revamp, everybody was up against me. But when I proved mathematically that hey, this is taking this much time, and with my work what I'm suggesting, it'll become this much, just like what we did today, right? And it suddenly became one of the coolest project in the team. Okay, suddenly, while all of the were junior members were not junior members were, saying that, oh, this is a boring work, this is not great and all that, all of them actually started loving that project suddenly because it was a revamp, and revamp with the mindset of improving its performance. And performance was very something that is, changed the paradigm. And we did succeed to a very, that's what is being used in production as of today. And so the point I'm trying to make is, if you pour your heart into it, if you embrace the problem, if you look at the problem with a kind eyes, from the perspective that what can be done. Okay, instead of figuring out why it's happening to me, or whose mistake is this, whose mistake is that, or is it good enough, is it bad enough, right? Instead of looking at this retrospective way, you always look at what can be done. Okay, that's one question that you should have ready. What can I do now? Whatever happened has happened, but what is it that I can do? So that if you keep that in mind, I think every work will be interesting. And no matter what kind of work you get, it'll be joyful. Whether you're working in a company or you are doing this startup, if you do not enjoy the journey, you will not be able to sustain or survive in that. All right. So the most important part is, right, because if you enjoy a journey, like for me, coding was a joy. A lot of things, a lot of systems was a joy. So spent a lot of time with it, right? If somebody puts a gun on my head and says that you have to sit and stare at the screen and do nothing, I don't think I'll be able to do it. So it's the joy of creating things, joy of doing things, right? That's a far bigger force than the compulsion. Okay. And with respect to certificate, you'll get certificate automatically. Just go to this project and finish this project from end to end. Okay, and you'll automatically get the certificate. Okay, you will get this link called request certificate, and click on that, and you'll get the certificate. I think I'll get the certificate. You can download. Oh, nice! I got the certificate. Wonderful. So many very deep questions you guys asked. I'm happy to have all of you in this session, and I'm happy that you made this whole discussion very fruitful. Your one person's question would be useful for everybody. Okay, so thank you, Sherry. Thank you, everyone. Wonderful set of questions. I loved your questions, and and uh, and so on. Okay, so wonderful. Thank you so much, and have a good day. All right. So here is my certificate. I'm going to post it. Wonderful. Perfect. Perfect. And thank you so much. And these couple of questions were very emotional to me, and a bit digression was necessary. But at the end of day, I thoroughly enjoyed your questions. Keep it coming. Subscribe to the channel. Come over to CloudxLab. And trust me, you're going to do great in your career. Thank you, everyone. Thank you so much. All right. All right. Thank you so much. I thoroughly enjoyed your questions. And all right. If anybody has any question for me, and I love to